Okay, please scan the QR code. Scan the QR code, and I will start the course. Oh, by the way, before we start the course, I'm planning to have a second quiz. Okay, I'm planning to have a second quiz, probably next week. Probably next week. Maybe for you, maybe Thursday next week. Uh, it will be about the uh, chapter 3, drift. I will write some notes for you. Okay. Okay. I hope you have scanned the QR code. I will share later if you need. Let me start with the quiz arrangement. So quiz 2. I will write quiz and then midterm. So quiz 2 will be around uh, next week. So you have Tuesday and Thursday, right? But can I ask you which one do you prefer, Tuesday or Thursday? Thursday, okay. Okay, this will be your quiz. Uh, the topics will be about the derivatives, chapter 3, which is the topic title is differentiation rules. This will include I think from the product rule, quotient, basically most of the derivative rules, okay, including the log, the inverse trigonometric, uh, the chain rule, implicit, um, linear approximation, mm, and also the related rates. Okay. The questions may be around 5 to 6 questions. Uh, at least the related rates will be one question. The other will be either combinations or separate questions regarding this whole topic. Okay, that's the quiz. Okay, and for the midterm, uh, it is around, if not 12th of November. So this is November. It's 1 week after, or the next Tuesday. So it's 17 November. Okay. It depends on our lectures, okay? Because in the midterm, I'm planning to have chapter 1 until chapter 4. So chapter 1 is function. Chapter 2 is the limit. Chapter 3 is the derivative or differentiation rule. And chapter 4 is application of derivative, which is now we are studying the chapter 4, the applications. The application is basically we are dealing with the functions and how to graph the functions using the first derivative, the second derivative, finding the maximum, minimum value. Yeah, I think that's most of the chapter 4, and also the last part will be about the optimizations in the chapter 4. Optimization. Optimizations means your maximum or your minimum value. Okay, so you have it's similar to related rates. Okay, but the difference is in the optimizations you are looking for the values that are minimum or maximum. Okay, okay. Uh, do you guys have already have schedule for other courses midterm? Like physics when? Huh? 10 November. So 12 or 17 is not a problem. Or do you prefer 17? So can we decide now? When will you have a midterm? 17? Okay. So 17 will be uh, this will be Tuesday. Okay. So if we have uh, before midterm, if we have spare time, let's say we are not really going into another chapter, I will have some review. Okay, I will have some review for a day, at least one uh, one lecture before the 17th. Okay, I will have a review if we have time. Okay, if we have time. So probably the review will be on Thursday before. Okay, and you will also have TA for Friday to prepare the Tuesday midterm. Okay, I think that's the announcement. Um, Last time we are dealing with these functions, right? So we are dealing with the functions. Okay, so 12x minus x cubed. Okay, so if you have a function and you have the interval on that specific function, you have specific interval. Uh, you don't really usually when you derive equaling it 0, you will get max or minimum, right? But when you have the interval, you need to check the interval and check within the function whether it is maximum or minimum. Okay, and I think at the beginning, I think some of you asking about the Newton's method, right? I think you, right? Hmm? It's on. On. Test, check, check. It's on, right? This more clear? I think the problem is the mic. The settings. Okay, I will just using this. Okay, I think one of you are asking the Newton's method. I think you, right? Asking the Newton's method. Okay. So what's the difference linear approximations and Newton method? So I will go back some review. Okay. So linear approximations, Newton's method, and also tangent line and mean value theorem that we have learned from the chapter 4. All these four, okay, actually they all has a similar expression, okay, which is the expressions from the regular a tangent line. So y or to, okay. Okay, this is an expression, linear expressions that you have learned like many years ago, right? So basically, what we are dealing is the gradient. What we are looking at is the gradient. The gradient is the f prime, right? Or we can say this is the tangent line. Okay. So all the tangent line, mean value theorem, and linear approximations are based on just this linear. How about the Newton's method? It's also the same, but Newton's method works when the intercept is 0. Okay, the intercept is 0, because the purpose of Newton's method is to find the roots of some functions like that. Okay? So if you have functions like this, you know that at this red color, okay, this red dot, okay, this is your roots, right? But sometimes if you have difficult functions and you don't really have tools to graph, I think you can just use the graphing calculator or some website to draw the graph. But let's say you don't have tools to graph, and you only need to find the point here. What is x here? Okay, we can start approximating, okay, this x with another point. Let's say we have this x0. Okay, so x0, you have this is f x0. Okay, and we can approximate another x from this point, which is we are drawing the tangent line. Okay, the tangent line at this point, the x0, and the tangent line will crossing this x. Okay. Let's say the second x that we find is x1, which is getting closer to our truth, our real roots, right? And Newton's method, you can use it uh, as long as you want, as long as you can get closer, closer, and closer. You can have many iterations. Okay, so iteration, meaning it's repeatable. So basically, Newton's method is this whole the whole equations, but you are writing in x. Let's say this is x1 minus the function a slight delay. Okay. Let's say this is let's say the x0 based on the graph. It's the x0. Let's say it's x0. This is when the f of x is equal 0. Okay, yeah. So basically, this is the expressions for the Newton's method, which you can see this is the same expression as our tangent line, but the functions is 0. Okay, meaning when the function is 0, it's basically this point, right? Okay, and then you can repeat all of these informations with another x. Let's say the new x is x1. Okay, as you can see here, the yellow one is x1, the new x. Let's say this is the x1. and you want to find the x2, you can use the x1 and plug in x1 to the function. Okay. Oh, by the way, the Newton's method, because I already mentioned last week to you, okay? But actually, this is in the chapter 4. Okay, I'm moving the Newton's method to the front to see that the similarity between the linear approximations, the mean value theorem, and the Newton's method, and of course uh, the just the linear equation of the tangent line all is similar. Okay? The difference is how we approach. Okay, when we say approximate, it's not equal sign. It's approximating. It's not the exact value. That's the difference. Okay. I hope uh, you get the idea, okay, of the Newton method. Okay, now we going to continue our chapter 4. And I will start with giving you some equations, functions to solve, and then we can go to the next section. Okay, that is the G. Uh, find the critical point. And then second, uh, find the critical point. Okay, so you have two functions. Um, first one is functions G. The second one is H. Okay. The second one is using an absolute value. Okay, the functions g, if you try to find the derivative, it is the 4x cubed. Okay, and then you want to make it equaling 0. And maybe you want to factorize x. Okay, you have two expressions, the x and the other part of your quadratic. Okay, I hope you still remember the quadratic formula for quadratic function. Minus b plus minus b squared minus 4ac divided with 2a. But I hope you still remember. So this is called, usually we call it d, it's the determinant. Okay. So if d is less than 0, meaning you are having no real solution. So you will have an imaginary number. Okay. Imaginary number is if you have minus, it's defined as I. I think in calculus this semester we won't really go to imaginary. So this whole equations is having no real solution. So the only critical point you have is when x is 0, the gx or g0 is 1. So 0, 1 is your critical point. Okay. An absolute value, I hope you still remember how to solve absolute value. So you can have the positive and second is the negative. Or you can write this as positive and the second one is negative. But one of them you need to have an equal sign. You will find that your point, if you graph this absolute value, should be at let's say this 1, 2, maybe around here. 4/3. Let's say this is the point. Yeah, just illustration, not really scaling really well with the proportions. But let's say this point is 4/3 from our inequality here. Okay. So when you get this absolute functions, okay, when you try to derive, okay, maybe you think that okay, I need to find my h prime equals 0. Okay, but when you have the h prime from the absolute value of 3x minus 4, it's already linear equations, right? So your h prime is just 3, right? Where the 3 is, it has positive, it has negative, right? And as illustrations in the graph, you will have 3 and -3. But the problem is, it's not a problem, just information. So here, okay. So you see that at this point here, it's not included in the equation. So the critical point is, we still say this 4/3 is our critical point. Okay. Okay, just notes for future reference. Okay, so if you have absolute value, always remember to think as a piecewise defined function. You have the positive one and a negative one. Okay. Okay, I will give you one more to give more introductions for the next section. If you have the function, okay, find the you have x minus 1, and then you get a cube. Okay. You see, this function is quite, if you remember the x cube, okay, if you remember the x cube, the function's x cube, let's say we have the gx is x cube. The f of x is actually the same functions as x cube, but you move to the right 1 point, right? So if you can draw the x cube, imagine that the functions looks like, then you need to think, okay, what is the critical point, okay, from the cubic function? And I think it will be having a similar behavior in other odd functions. For example, x5, 7, and so on. So let me write some notes for you. So odd functions and even function. Even function usually symmetric. It's symmetrical. The odd function is asymmetric. It's like the x squared, the x cubed. Okay. The symmetrical meaning left and right is you can mirror the image. Okay. But asymmetric, for example, like that, you cannot really mirror the image. Okay. How to test the odd and even? You need to plug in negative x. Test the negative x. In the x squared, the negative will be positive, right? So that's why it will be the same. But when the x cubed, it is negative, right? This is positive. So let me write, okay? So f minus x is fx. This is for even. And if you write and it's get negative, then this is odd. So you can have like really complicated rational functions, maybe x plus 1 over x to the fourth plus blah, 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 blah. You can check with the minus x. Okay. Check whether it is the same functions or it will be changed to the negative functions. If it is the negative function, then it means the odd function. It can be useful when you sketch the graph, okay, using the derivative. And when you sketch the graph, if you think that this is the even functions, then you will have a symmetrical functions. Okay, like the maximum and then the minimum, it will be easy to predict. Easy to predict. Okay, so back to the x minus 1 cubed. Okay. So if we think by definitions, like in the last discussions, so every time you have f prime is 0, this is still critical point. Okay. So if you have f prime 0 from the functions, this is 3x minus 1 and then squared, and it's 0. So x is 1. So what is x equal 1 means? Okay. If you want to check, okay, uh, the first derivative test, okay, let me write the f prime test. This is to check whether it is going from positive to negative or from negative to positive, or maybe the same signs. Okay. So check whether f prime is greater 0 or f prime is less 0. If you check with any number less than 1 and greater than 1, we will find this is actually keeping the same sign, right? And if we see the graph and imagine the x cube, okay, I will just give you the graph. Wait. Okay, this is the graph. So if you see the graph, okay, it's going up and it's still going up, right? The gradient is positive, the slope is positive, and this is also positive, right? But at x equal 1, it's still, the f prime is 0. So we still say at this point, it's critical point, but it's not maximum, it's not minimum, but it's critical point, okay? So this is critical point, not max, not minimum. Okay, then we now move to the next section. But from here, okay, this is positive, this is positive. I will show you some differences. Okay, let's say you have going up. This is also going up. This is also going up, like when we observe the previous graph. Okay. So all is positive gradient, right? So the gradient is positive. What is the difference? Okay, all these three graphs, this is just linear functions. This is some quadratic, also quadratic, but maybe difference plus minus. Both are positive gradient. But what is the difference? What is the difference? Okay. Maybe focus on this 1 and 2. What is the difference between these two? If I draw the full line or the full the functions, you will have maybe it's going here, maybe this one going to the left, right? You see, one is going facing down, one is facing up. Okay. We say the one that facing up is concave upwards, and the one that facing down is concave downwards. Okay. When in concave upwards, you will have your minimum here. And when you have concave downwards, you have the maximum. Okay. So in your cubic formula, your functions is, okay, you see that it's half upwards and half downwards, right? Okay, wait a minute. Okay, in your cubic formula, you can have, this is your functions, the cubic. You can have half is upwards, half is downwards, right? At, and this point at the middle is the point where the concave change from downwards to upwards, right? At this point, okay? At the point in the middle. Let's back to our previous questions. Back here, okay? So at this point, the 1, 0, this is x equal 1 here. So exactly at this point, this downwards is changing to upwards, right? That point is not only critical point, but we say this is the inflection point. So inflection point means when you have change in the concave or concavity, from the concavity downwards to upwards. We say it's inflection point. Okay. Okay, let me write some notes for you. So inflection point. So before we go through, let me remind you what is critical point or turning point. Okay, turning point or critical point, this is positive gradient, and at this point here, it's 0, and then become negative, negative, negative. Okay. So the gradient change, the gradient change, okay. Point where gradient change. And inflection point, change in the sign of concavity. Okay, probably I have kind of functions to see where the concavity changes. Let me draw the arrow where the concavity bending. Okay? So it's going here. It's facing down, right? It's going upwards, and then maybe after some point here it changes, right? And then it will going uh, probably here. It's not really good, but it's just zero here, and then maybe it's a little bit going there, and then zero, and then it's changing to here, and maybe at some point here it's changing, and then again changing here. Okay. Okay. So I hope you get the idea or the definitions from the graph. Okay, where the concavity change from the upwards to downwards, or respectively from downwards to upwards. Okay, we call that point is inflection point. So we have this in this and this, maybe here, also in here also it's inflection point. To evaluate the inflection point, we can use the second derivative. And then from here, you can have when inflection or when the second derivative is greater 0 and less 0. When you have positive, meaning this is concavity upwards, and when less 0, it's downwards. This is like that. Okay. Let me give you some graph to check and observe. Okay, let's start with simple functions. Okay, let's start just with the. Let's just start with basic functions. Let's say this is fx is just x squared. Okay, let's draw the f prime and draw the f double prime. Okay. Does anyone still have confusion how to draw the first derivative and second derivative from x squared? Anyone still have confusion? Okay. So to draw the first derivative, you can check the gradient. Okay. So check the gradient. from the original functions. Check several points. If you see the gradient is getting down, right? It goes down, so it's negative, right? And after 0, it's going up. Okay. So you can also think from the equation itself. You derive and you get 2x, right? And probably your linear is like that. And this is true because you can check the gradient. This is in negative, right? And below 0. And here is above 0, right? So if you have like, because this is just a illustration from the simple function. If you have more complex functions and you want to uh, at least roughly sketch the graph. So from the functions, you want to sketch the f prime or the first derivative. What you can do is you can check this sign, check the sign, where uh, the the graph will be. Okay, check the sign and also check when the f prime is equal 0. F prime equals 0 is at this, right? So you check the uh, at the horizontal tangent. Okay, that point is 0. So after 0, it's changing the positive. Okay, so here it's changing from negative to positive. Okay, it's also correct. So how about the f double prime? This is just 2, right? So you can just having. So I will write this is no change in sign, right? Because it's just a constant, which is positive, right? And how you are relating this from before. Remember, if you have f double prime greater than 0, meaning your graph will be like this, right? Which is true. The original graph is upwards. Okay? It's concave upwards, which is true when you derive twice. It's 2, just a constant positive, right? So it's true that it is concave upwards. This is a confirmation from our previous inflection point. Okay? So there is no inflection point here because the concavity is just upwards. There is no change in concavity. Okay, you just have the critical point. But critical point can be an inflection point. Okay, okay, I will give you the. I think we can just start with simple function first. Let's say you have uh, should be, let's say this is the x cube like I've told you before. The x cube, f prime and double prime. Wait a little bit. Okay. But let's try the x cube. Okay, so try to find the f prime and f double prime. Try to sketch the graph. Okay. Do you feel hot? Do you want to turn AC or no? Okay. Can you help me turn this to? Well, let me write the derivative. Okay. The first one is just 3x squared, and the second derivative is just 6x. Okay, the idea is because this is a simple function, and you can see it's just a quadratic, and then this second one is the linear, you can imagine easily. Okay, but what I want you to think is think of the signs. Okay, think of the signs, the positive, negative sign. It, what's happening? Yeah, can you check? Maybe the settings. Okay. Okay, the 3x squared. Let's just checking our gradient. Okay. This is positive, 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 all positive, right? So when we think the 3x squared, we know that it's just a quadratic function. Maybe it's about that. But think that all this x here is in the positive side, right? It's all positive based on our gradient. Okay, this is positive, all positive. Uh, you might be confused why I'm writing positive. I will write this is positive sign all around. But the gradient from this will be different. So writing down here, this is going down, right? The gradient. And the gradient on the right side is going up, right? But all this y is positive, right? Based on that point. And the linear, the second derivative is from negative to positive. So from here to here, right? And maybe like, so this is from negative to positive, okay? And okay, let's try graphing these functions. So try to graph f prime. You can draw in your paper. Just draw necessarily, not really in a scale or in a number point, okay? Just to think, if you have this as your function, what is your f prime? I hope you can see it's from the beginning, it's concave downwards, and then it has bending here. So it's also downwards, and it's going up here, and it's upwards at the end. Okay, try to make the f prime, the first derivative. So the important point to graph is to imagine the f prime is your slope, right? And what is the slope behavior? What is the sign of the slope? You need to think, okay, when the sign changes, okay, from in which, at least in which point, you need to also think that. Yes. Okay. And probably you can also use the second derivative to check also. Because second derivative, uh, you can use that for to check when the graph changing from upwards, downwards, downwards, upwards. Okay. You can also check that. And maybe in the example or in the problem set in the textbook, sometimes the graph is not the functions, it's the f prime. It can be also. And maybe you need to think what is the original functions, or maybe what is the second derivative. But the idea, okay, how you solve all the graphing is using the first key point is using the f prime. Okay, I will write. Okay, I will write for you. So key is check f prime. Okay, and the most important f prime is when f prime is 0. Check when is f prime is 0. At least I have 1, and then this 2, and 3. So at this 3 point, my f prime is basically crossing this x at this x, right? It's 0. Okay. So to give you a better understanding, I will try to graph the f prime in the same y and x axis. Let me draw the line for checking the sign. And let me mention the f prime. So first here, second is here, and the third one is here. So this is f prime is 0, f prime is 0. Okay. Now we have 3 points here. So point 1 here, 2, 3. Okay. We don't really know the number, and we don't really care now. Okay. At this point, see the left side. It's going up, going up, going up, right? It's positive. Okay. And then after this point, it's negative, right? Let me write the notes. So here is f prime is greater 0. And this is f prime is less than 0. So it's positive, it's negative. So the first derivative will be from positive to negative. So from up to down. And it will crossing exactly this point here. So it's crossing here. Okay. Okay, now you also have the, if you think of inflection point, you also can check this one. Okay, but let me just mention as a dash point. Okay, at least like this. Yeah, and then at this f prime 0, I will write another notes here. It's still going down, right? Still going down, and then lastly, it's going up. The f prime going up. Okay. You can also see it from the right side. So it's going from positive to negative. And also we can see there is a change in concavity here. Okay? Let me draw the line first. It's both seems going concave upwards because both have the this is less zero, and should be the uh, from the graph here. These 2 points should be meeting here. Okay, so going here and going here. So it will have changing the concave upwards, downwards, and then upwards. Okay. If this is like our the x cube, it will be like this, right? Yeah. Okay. So if you have a functions, you can think that you can predict what the f prime looks like. But remember, this is just a roughly sketches. Okay? This is just roughly sketch. We don't really necessarily calculate the number exactly. But at least, okay, at least we predict that the curve, it might look like this. And you can also check if you want to make the double prime, the second derivative. You can check the slope. Okay? When the slope change, I think the important is in here, in the middle. Okay? You're changing from here, negative, and then positive, right? And then negative, and positive. And you can see that you can prove that this is really changing the concavity. Okay? But at least by checking the f prime, especially the f prime is 0, we can predict what is the graph of f prime. Okay. Okay. Any questions first? Any questions? Okay. Do you think if I giving you a graph like random like this blue graph, can you try to figure it out how to find the f prime, f double prime, or still confused? If still confused, maybe I will later I will give you another example. Um, yes. Which one? The yellow one? This? This? Okay. Okay. Good questions. Okay. So why the yellow one is looking like this. Okay. So first, we need to think the idea is came from the f prime is equal 0. Okay. So we need to have at this exact point, my f prime is 0. So let's just making this point, this point, this point. It should be 0. Okay. When you are moving the point, okay, based on the gradient you have, at the whole left here is going up, right? It's positive. Okay. At this point, it's going down, right? It's going down. Maybe I can draw like this, right? But remember, I still have f prime in this middle. So I need to change my direction. Okay? Even though maybe I don't really care about the concavity. Maybe I don't really care about the inflection point. But I need to have my x at the 0. And I'm still going here. What should I do? I need to turn back, right? Got the idea? Right? So I need to turn back here so that I get x is 0, right? You mean like this? Why? But it's, remember, this is less 0. So it should be going down. Okay, it should be going down. This is whole the negative part. Okay, so here. So all the positive is here. This negative is here. Okay. So this is positive. Okay. So all this positive, 0. And then this part is negative, going negative, right? But I need to have another 0 here. I need to go up. But I'm still in negative, right? Up until here. Okay. And from here, I need to go here, but I am still negative. Or I need to go to negative, right? I need to group with my friends, the negative one, right? And then after some point, I don't know this exact point. I don't really care now. Okay? But I want to go back here because it's 0. So going up. Okay? If you want to check, you can check from this f prime, check the f double prime. You can check, I think just this middle one is the important one here. So this is going down and going up, right? So it's negative, positive, right? So it will be crossing that point, right? At the exact point there. Exact point here, it will crossing here, the f double prime, okay? And this point, this also 0, 0. So it's going back here, and then check here is the slope is negative, and this is positive. Okay? So it should be going there, right? Okay. Okay. Uh, because I think uh, some of you still asking some questions from the related rates. I have some problems that you can practice on. And because also our quiz having related rates, and I want to know whether you are understand the concept or no or no. Okay, I will stop the chapter 4 under here, and we will turn into the related rates problem. Okay, is that okay? I think some of you are still confused about the related rates. Okay, let's check this. Yes. Later. Let's go to related rates, and I will move back to. Okay, try to read the questions and solve it. Okay, so you have a straight line, 6 meter tall, and you have a man, 2 meter. He walks away with certain speed, a straight path, and how fast is the tip of his shadow moving. So I'm trying to drawing a picture for you. Okay, so a man moving in the straight path, and imagine you have the lamp, okay, and the lamp illuminate the lights, okay, and it will give a shadow. Okay. The question is when the man is moving, how fast the shadow is changing, the rate of change of the shadow. Think if the man is here, maybe it will be going here, and maybe it's smaller, right? And maybe in here, it's like this small, and then the length is changing. The length of the shadow is changing. Can you find how fast the shadow is moving? Okay. Okay. So in related rates, the most important one of the key point is to draw the diagram. Okay. If you draw clearly and you understand the problem, then it will help solving your questions here. If you draw and it's wrong, then maybe you won't have any solutions at all. Okay. So you draw this diagram. Okay. See if you can think any relations from this diagram. Think any relations, maybe geometric, or maybe it can be area, and any simple terms in math. Okay. Usually, related rates will be dealing with simple geometric formula. Um, I think I've told you about the circle, the triangle, right? I think this is also a triangle, right? Simple triangle geometric. Okay. So anyone find the answer? Okay. In high school, um, you learn some physics, right? Have you learned like simple thermodynamics in physics? High school, like thermodynamics. Uh, do you still remember the Gibbs delta G? They have delta H for enthalpy, delta G. Uh, delta G, we call it's the Gibbs or Gibbs. How to say it? Yeah, Gibbs. It's the free energy, right? But the idea, okay, that I want to tell you is every materials, every physical object in the universe, they all tends to have um, okay, let me tell you here. If you wake up in the morning, really early in the morning, and you have choices. You get up early, or you choose to sleep 5 more minutes. You choose 5 more minutes, right? Okay. So every physical object in the universe, every materials in the universe that have in physics, they are in physical phenomena. They have their physical phenomena. They tend to go rest. They want to go rest. Uh, you know iron, right? Iron for buildings, right? Um, you know corrosions, corrode. So when the iron maybe it's getting influenced by the air, by the water maybe. You will see it become rusty. The color may be red or brown, right? So the brown or red color is the shape that the material wants. It's the original shape of iron. You see, iron you will get iron from some mining, right? You mining and you get the ore. You put the ore in the hot furnace. You are boiling the ore basically, and you get the pure iron that you want to use, and it's really strong. But when it's still iron ore, it's really brittle. It's sometimes it's useless, right? But the ore itself is the original uh, form of the material. So it's the materials want to go to that form. So when the materials or the iron getting influence from the air, it's try to get rusty because rusty is the preferable positions. Like you want to wake up, but still have choice. Okay, 5 more minutes. Okay, everything in the universe is they want to go lazy. They want to get rest because it's really enjoyable, right? So the idea is, okay, if you want to survive, getting a job, learning something, everything, do not make your life harder. Okay, so it's like you do like minimum effort, but it has a maximum output, and you need to optimize that. Uh, Maybe every professor will give you like information. Wow, really a lot, right? Imagine you are like hard drive in your computer, maybe external hard drive. Okay, you put the external hard drive. You try to read a book, try to memorize something. But when you remove the hard drive, all the information is okay. Bye bye information. So sometimes when when I was still in high school, I learned a thing and I get maybe good score in the exam, but I forget what is that thing at all, and I remove it all from my mind because I have a wrong mindset. Okay, that is wrong way to study. Okay, to study is like an internal hard drive. Okay, it's internally attached to yourself, but internal hard drive usually small, right? Like in your phone or iPhone. It's just like maybe only 64 gigs or 128, right? The standard hard drive. So within those space, make sure the information you get is the key, is the foundation, is the fundamental concept. So when you have that fundamental concept, wherever you go, you will always get the idea. Okay? So every time you get meeting with a professor or getting some information from courses, try to get a basic idea or the concept of that idea. Okay? Maybe practice is maybe it's helping you practice, but it's not always the case. If you're practicing the wrong way, you will get nothing. Okay? Except getting how to solve the problem in the question set, which is not a really good way to approach. You need to really understand the concept. Try to make your life easier. My advice, be like that iron ore. Rest. Be lazy. It's crazy, right? But smart. Okay? But smart. Be lazy but smart. Okay? I know that you will be tired. You'll be you need some relax. So I don't mind if you want to have like some snacks in my course. You want to eat some snacks. Maybe watching YouTube video, but don't make noise. Okay? Maybe for 5 minutes, like watching cat video. Oh, that's funny. Okay? And then maybe some funny video like comedy, like slapstick. Oh, okay, funny. But then try to focus one more time. Relax is a good point to refresh your mind. Okay, you need to also to balance your life. Okay, don't make your life harder. Uh, the idea for the course is okay. Passing the course with good exam is a bonus, but it's important to just having a good concept, knowledge of really basic foundation of all the um, because we are dealing with engineering, so we got to go there, right? Science, technology, engineering. Get the basic. It will help your life easier when you find a job, when you are meeting a new customer, if you are working. It will help you can adapt easily in your new environment, okay, after you graduate. Okay, so that's my advice. Okay, sounds crazy. Be lazy but smart. Okay, but smart. Lazy but smart. That's what I like. Okay? Lazy but smart. Okay, back to the course. Okay, anyone fine? Okay, 3.75 is what? Uh, okay. I get this the idea. Okay, so but the key of related rates is checking this triangle, right? See if I can find relations. Okay, so this is 6, this is 2. Let's say I will have this is X and Y. Okay, the person is moving from this position, from this tall straight line, and he will moving here. So actually, if you see this X and Y, the shadow is all this part, X and Y. Okay, and we can see the relations from simple geometric. I think you learn in junior high or elementary. I forgot. But you can write this as y over 2 is equal x plus y over 6. And then you can solve this. You get actually y is half x, right? Okay, and then what we do now? So because our distance is x and y, so what we are doing is we just derive x plus y. And y is just half x. So we derive 3 over 2x. And then we get 3 over 2, and then dx dt. So dx dt is our 1.5. So this is 1.5. So it will be 4.5 over 2. It's meter per second. Or I will show you the whole what I did. Okay. So I simplify the shadow, the x and y, both of this. Okay. And the man moving from this left side going to the right side. Okay. So the man will cover the x and y respectively, right? So he will go through x plus y distance. So the shadow will change through this x plus y distance, which is just derivatives of x plus y. So derivative of the distance, this distance. Okay? And how we get the relations for x and y, we go to this simple triangle and see the ratio between this triangle, okay? Between two triangles, the big triangle and the small triangle. You use that ratio, you get y equal half x, and you get 9 over 4 or 4.5 over 2. Okay, so the 10 meters is not really important in this case because the man will go with proportional ratio 9 over 4. So every x he has, 10, 20, he will go 9 over 4, constant. Because there's no information whether he is changing his speed or not, right? So it's just because he's just using constant speed, so just 9 over 4. Okay. I think one more, just one more, and then I can conclude the class. I think someone asking me the wire, the density of wire. Actually, the linear density itself is in the chapter in chapter 3, 3.7, the rate of change in natural science. But I just gave a few, but I'm mostly skipping it because I think you will get easily understand with other courses. In that chapter, it has linear density, rate of reactions in chemistry also. So here's the idea, okay, to get the idea what is going on here. Okay, this is a wire, okay? A wire is just like a cable like this, right? So it's like a long in length, really, really long, and the radius is really small, right? So you have an x, for example, for the length, and maybe this is really small here, really small. Okay, so the idea of let's just start with the density. The density is the mass is divided by volume, right? Okay, so imagine the wire, okay? The wire is really long, and then to simplify what is going on in wire, let's just think in one axis, just this distance. do not really think about the area of this the circle here. Okay? So let's just ignore this side. So let's just look at the distance x. Okay. So density mass divided by volume. Linear. So you get the idea. Linear. Linear means it's only one axis. So you can say that the density, the linear density, is rate of change of mass by length. Okay. So let me write the density is actually dm over dx. Okay, that's why I told to you, right? Make it dx, make it really small. Okay. So if the m itself is x, so we need to find the m over dx, which is 1 plus x. And then when x is 4, then dm over dx, this is the density, the linear density, is 1 plus 2 plus 4 to 4. So 3 plus 1. So it's 4. 4 kilogram over meter. So linear density means the density over just the length. Okay. Okay. Have you learned something with your TA last time? He gave the related rates also, or no? Last time, the TA give. Oh, okay. And how about the TA? It's okay. Okay. I think you guys have different TA, right? According to the program. Okay. But how about the TA overall? It's okay. So TA, okay. How about the international students? Your TA is okay. Okay. TA, okay. Okay. If you have any suggestions, I think last time you, I think someone say to Irene, right, about the TA. Okay. So if you have any problem with your TA, maybe some suggestions, just please let me know. Okay. 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 Any questions here? Any questions here? Okay. Okay. So basically, every related rates, every problem in related rates, you need to think more simple. Usually, you need to simplify some formula. Okay. So like this one, you don't really need to think about the volume. Okay, so you need to think of what this linear means. Linear means only one side, right? So probably it's just the distance, this distance, whole distance. Okay, because you are ignoring the part of the wire which is the surface area, right? The circle. Okay. Okay. If there's no questions, I think stop here. Is that okay? Okay. Okay, and see you next Thursday.